Welcome to part 1 of the Semester 1 Pre-Calculus Final Review Packet. Question number 1. Find the distance between two given points. Now, with this problem, you notice that they have the same x-coordinate, so the distance is just simply the magnitude or difference between the y-coordinates. But let's go ahead and do the long process, because on the test, they may not just be a vertical or horizontal distance. So we'll start off by labeling the points x1, y1, and x2, y2. Now, if you don't have the distance formula memorized, you may want to jot it in your notes for the final. So for each of these four values, we'll plug them into the appropriate spot in the formula. So x2 minus x1 would be 6 minus 6. And then y2 minus y1, 5 minus negative 3. So I get 0 squared plus 8 squared radical 64, which is simply equal to 8. Now in number 2, we're asked to find the midpoint of a segment, and we're given the endpoints. So like we did in the previous problem, we're going to go ahead and label the coordinates x1, y1, and x2, y2. So here's the midpoint formula. Once again, if you don't know it, you want to put that in your notes. So I'll substitute the four values into the appropriate spots. So I get negative 16.8 plus 5.6 divided by 2. And then for the y-coordinate, 12.3 plus 4.9 divided by 2. Now, you need to be careful when entering these into the calculator. If I want to enter that in one line, I should put the top part in parentheses. Divided by 2. And so I get negative 5.6. Then for the y-coordinate, .6. And there's my answer. Now, this is a common mistake I still see. Let's say that I inappropriately put the left side in the equation, or the left point, x-coordinate, as negative 68.8 plus 5.6 divided by 2. Now, because I didn't put parentheses, I'm going to get a different answer, which is the wrong one. So make sure that if you want to do it in one line, you put parentheses around the top part. Okay, number 3. We have a triangle. These are the vertices. And we're supposed to show that the lengths satisfy the Pythagorean theorem, which means we need to find the distance between each vertex. Now, for these two, notice that they have a common coordinate. So here we can see the distance between 4, 5 and 4, 2 is simply 3. And for the bottom set, the distance between 0, 2 and 4, 2 is simply 4. For the top one, since we have an oblique segment, meaning it's not vertical and not horizontal, we'll go ahead and use the distance formula. So 0 minus 4 squared plus 2 minus 5 squared. And so we get radical 25, which is equal to 5. Then to show that they satisfy the Pythagorean theorem, we know which is a squared plus b squared equals c squared. We'll take the two smaller distances and plug them in for a and b, and the hypotenuse c. And we get 25 equals 25, which shows that the lengths satisfy the Pythagorean theorem. Okay, number 4, find the standard form of the equation of the circles. So here is standard form for a circle, where HK is the center and R is the length of the radius. So for part A, we're given the center, so that's my H and that's my K. And then I'm given a solution point, which is simply a point on the circle. So we need to find R. So what is the distance between the center and the solution point? So negative 1 minus 3 squared plus 1 minus negative 2 squared. So the distance between the 2 points is 5. Now, alternatively, you could have plugged h and k in for h and k in the equation, and you could plug negative 1 and 1 in for x and y, and that will give you r squared. I prefer this way because when we write the final equation, some students get confused and put the x and y values from this part in there. So if the distance is 5, that means the radius is 5. So let's write the equation. X minus h squared plus y minus k squared. Now k is negative 2, so instead of writing y minus negative 2, we're going to write y plus 2. And then 5 squared is 25. So that's the equation for A. For B, I'm given the endpoints of a diameter. And I know that the center of the circle is simply the midpoint of that diameter. So to find the midpoint, I could use the midpoint formula. And the center is at 0, 0. So like I did with part A, I still need to find the radius. Now I've got 2 points to choose from and to find the distance. I'm just going to go ahead and use 4, 1. So 4 minus 0 squared, 1 minus 0 squared. And so the distance is radical 17. So the radius is radical 17. So writing the equation, x minus h, so x minus 0 squared plus y minus 0 squared equals radical 17 squared. So x squared plus y squared equals 17. Okay, for number 5, we're given 2 lines and 2 points on each line. And just so you know, those are supposed to be commas, not periods. And we're supposed to determine whether they are parallel, perpendicular, or neither. So let's recall the relationship between parallel slopes. Parallel lines have the same slope. And then perpendicular lines have slopes that multiply to -1. Now, the only exception to this statement is when you have a horizontal and vertical line. Because a vertical line doesn't have a slope, it's undefined, we can't really multiply those together. So let's go ahead and find the slope of each line. Here is the slope formula. So for L1, y2 minus y1 over x2 minus x1 so line L1 has a slope of 2. We'll then do the same thing for L2. y2 minus y1, x2 minus x1. And we get a slope of -1/2. So it's obvious to see that they're not the same slope, so these two lines aren't parallel. Do they multiply to -1? 2 times -1/2 is -1. So these are perpendicular lines. Another way is that perpendicular slopes are opposite reciprocals of each other. So 2 is 2 over 1. If I flip the fraction, I get 1 over 2. And the opposite of 1/2 is -1/2. So that's another way to look at it to see if they are perpendicular. Well, that ends part 1. We'll start with question 6 on part 2.